Welcome back to the topic on electron gain enthalpy. Now let us see the variation of electron gain enthalpy across the period. Now in the previous video we have seen three important factors affecting the electron gain enthalpy. Those factors, if you recall, those factors are atomic radius, second one nuclear charge, and the third one is the electronic configuration. So by considering these three factors, we can explain the variation of the electron gain enthalpy across the period. Suppose you move from left to right in the second period: lithium, beryllium, boron, carbon, nitrogen, and then oxygen, and then to fluorine. We observe that the nuclear charge goes on increasing, the radius gradually decreases, and in some cases the stable and half stable configuration with the filled and half filled configurations. For the last element, let us consider neon. When you consider this lithium to beryllium, lithium has got 2s1 while beryllium has got 2s2. An electron can be easily added to this lithium as compared to beryllium. That's why in this case, in case of the lithium to the right side, when we move from lithium to the right side, the electron gain enthalpy becomes more and more negative. But there is no regular variation in the trend of this electron gain enthalpy, because at some cases we have this completely filled or half filled configurations. Okay, exceptions. Beryllium has got positive, nitrogen has got positive, while neon has got positive. Otherwise, there is a gradual increase in the electron gain enthalpy. Increase in the electron gain enthalpy means it becomes more and more negative. Okay, it is because of the decrease in the atomic radius, increase in the nuclear charge, which are actually more favoring this electron gain enthalpy becoming negative. But in case of the electronic configuration, when it is half filled or completely filled orbits, in this case it is completely filled. In this case it is half filled, 2s2, 2p3. In this case it is completely filled again, 2s2, 2p6. For these three elements, the electron gain enthalpy becomes positive. Otherwise, there is a negative. Lithium also has got very small size, and it is more metallic rather than electronegative element. That's why for this also we have this positive value. But comparing to that one, there is a gradual increase in the trend to accept the electron. For down the group, becomes electron gain enthalpy becomes less negative as we move down the group. Just you will observe, atomic radius gradually increases. Even though there is an increase in the nuclear charge, attraction decreases, and for the same reason, electronic configurations in certain cases which give extra stability, there will be positive or less negative elements. Then in case of the halogens, especially these halogens, actually in the second year in the P block elements you will study this important point. In any particular group, the second period element has got a exclusively small size. So comparing to that one, third period elements have got little larger size. And hence, comparing to the second period elements, third period elements have got the larger negative electron gain enthalpy. So, electron gain enthalpy of fluorine is less negative as compared to the electron gain enthalpy of chlorine. But when this electron gain enthalpy of chlorine is considered compared with the other elements, this becomes more for bromine and more for iodine. That is, from fluorine to chlorine there is an increase, and chlorine to bromine and iodine there is a decrease. Okay, so this is the trend that we observe in case of the electron negativity. Okay, now let us consider some graphical representation of the electron gain enthalpy. So graphical representation. Graphical representation. As I told you, it is measured in terms of kilojoules per mole. So draw the y-axis. Here we have electron gain enthalpy, which is measured in terms of kilojoules per mole. Assume that this is 0. This is minus 200. This is minus 400. This is plus 200. This is plus 400. For this hydrogen, it is around 100 something. Between minus 200 and minus 300. Then from hydrogen to helium, there is an increase. Increase means it becomes positive in this case, or 0. From minus 300 to 0 it becomes. For lithium it is around minus 200. Minus 200. From lithium to beryllium there is an increase. It is because in case of the beryllium there is a completely filled configuration. That's why it is having the positive electron gain enthalpy. From beryllium to boron and boron to carbon. This is boron and this is carbon. Compare this boron, lithium and carbon. Carbon is having more negative as compared to lithium. Boron is having actually 2s2, 2p1. There are some vacant weak p orbitals available, that's why electron gain enthalpy is negative. Again, when we move from carbon to nitrogen, it becomes positive. Just compare, this is 0. It becomes positive. It is because for the nitrogen it is having the half-filled configuration. From nitrogen to oxygen there is a decrease. From oxygen to fluorine there is a further decrease. This is fluorine, this is oxygen. More negative in case of this oxygen as compared to carbon, and again more negative for fluorine. From fluorine to neon there is an increase. This is because neon has got completely filled configuration. But when we move from neon to sodium, again there is a decrease in the value because of the 3s1 configuration. So this is the irregular variation in the electron gain enthalpy. So this is actually drawn against the atomic numbers. As the atomic number increases, there is a gradual irregular variation in the electron gain enthalpy. Especially in case of half-filled or completely filled configurations. Half-filled like nitrogen group, completely filled like second and 18th group elements. Except for the remaining elements, there will be a negative electron gain enthalpy. And special case that we have to remember is, in case of the halogens, fluorine is having exclusively smaller size. That's why it is having the lesser electron gain enthalpy as compared to chlorine. So from fluorine to chlorine there is a decrease that becomes more negative, and for bromine and iodine it becomes less negative. So this is all about the electron gain enthalpy. In the next video we will go for other property like electronegativity, and electronegativity, how to use that electronegativity to calculate the ionic bonding or covalent bonding, or ionic character in covalent bonding and covalent character in ionic bonding, etc. Thank you.